Hello everyone, myself Jia and I'm so happy to welcome you to my channel. Today we are going to dive into a very interesting and important topic, the use of gray code in position encoders and robotics. If you are interested in robotics, automation or simply love learning how smart machines work, you are in the right place. So, stay tuned as we break down this topic into a simple and easy to understand way. So, let's get started. Today, we'll talk about how gray code is used in position encoders and robotics. We'll see why gray code is better than normal binary, how it works, and where it is used to make machines more accurate. Here, what we are going to cover today. First, what is gray code? Second, what are position encoders? And then working of encoder disk, use of logic gates in gray code detection, use of flip-flops in encoder systems, advantages and applications, and then last is conclusion. So let's begin. So first we'll begin with the introduction. What is gray code? Gray code is a binary numbering system where only one bit changes between successive numbers. Gray code is a special type of binary code. In a gray code, when we move from one number to the next, only one bit changes at a time. This small change helps prevent errors when machines read fast moving parts. Now, binary to gray code conversion. Now, let's understand how to convert normally binary into gray code. As you can see on the screen, the first gray code bit is same as the first binary bit. After that, each next gray code is found by XOR the current binary bit with the previous binary bit. First 0 for binary is 000, for gray code 000. For 1 0001, for gray code 0001. As I have told that first bit remains the same. Then for 2 0010, and for gray code 0011. As you can see that only one bit of gray code of the successive gray code changes. So from the following table you can understand that how the one bit changes in the gray code. So it's easy in robotics to reduce the errors. Now, why is it important for robotics and encoders? Uh, it ensures precise position sensing by reducing errors during transition, making it essential for robots and automation. When robots move, they change position very fast. If we use normal binary, multiple bits might change at once, causing mistakes. Gray code changes only one bit at a time, making it highly reliable for reading positions without errors. This is why it's crucial for robots and automation. Now, now, characteristics of gray code. First, gray code is a binary numeral system where two successive values differ in only one bit. Second, minimizing the risk of errors in digital encoders and combinational circuits. The small change reduces the risk of errors. It makes gray code perfect for digital encoders where precise movement detection is needed. So, the gray code is very useful in place of the binary number. Now, what is a position encoder? A position encoder is a sensor that tracks the exact position of a moving object. In robotics, encoders help control joint angles, wheel rotation, and arm movement by providing real time feedback to the system. A position encoder is a sensor that tells us exactly where a moving object is. In robots, encoders helps to control how much a joint turns, how much a wheel rotates, how far a robotic arm moves. They provide real-time position feedback to the robot controller. As you can see in the figure, the basic position encoder setup. Here you can see the rotator, uh, then this encoder disk, this is optical sensor, and this is the output signals. Now, working of encoded disk logic level. First, disk is divided into multiple concentric tracks. Second, each track has light and dark sections representing 0 and 1. 0 for dark and 1 for light. Third, optical sensors are placed to read each track individually. And the last, fourth, sensor output a gray code pattern based on the detector, light or dark. So, inside the encoder, there is a disk that spins. This disk has multiple tracks like rings divided into light and dark sections. Each track is read by sensor. Light and dark sections represent 0 and 1s. When the disk spins, the sensor read the pattern and produce a gray code output to know the exact position. Working of encoder disk, as you can see in the diagram, that how sensors are placed at each track. As the disk rotates, the sensor detects the light and dark sections and send electrical signals, zeros or ones. Their signals together form a gray code representing the position. As you can see that the gray code output is here and the optical sensors are put in each track. Use of logic gates in gray code detection. First, sensors detect light or dark and output binary signals 0 or 1. Gray code is used to minimize errors during state changes. Logic gates such as AND, OR, NOT process sensor outputs, and the last, gets help decode gray code into standard binary. So the sensors produce a raw signals, but we need to process them to understand the position. Logic gates like AND, OR, and NOT are used to combine and clean up these signals. The logic gates help convert gray code into standard binary or make decision based on sensor output. Now, use of flip-flops in encoder systems. Flip-flops store binary outputs from sensors, hold data from gray code disk reliably, ensure stable and synchronized position data, commonly used D flip-flop for capturing sensor states. Here, flip-flops act like memory units. They store the sensor outputs so that the system can read them reliably. D flip-flops are commonly used because they easily capture and hold the sensor data at each movement. This ensures that each fast movements are captured properly without glitches. Now, safety in automation first prevents misread signals. Gray code changes only one bit at a time, reducing decoding errors during transition. Critical for safety, critical systems ensures reliable position feedback, vital for healthcare robots, industrial arms, and automated vehicles. Here, Gray code improves safety by preventing misreads. Since only one bit changes at a time, the chance of error during movement is very low. This is very important in robots used in hospitals, factories, or self driving vehicles where safety is critical. Application of gray code, as you can see from the diagram, first encoders, second robotic arm, AGVs, and automation. Applications, first encoders, accurate position sensing in motors and machinery. Second, robotic arms, precise joint angle detection. Third, AGVs, reliable wheel tracking for navigation. Fourth, automation used in sensors for feedback and control. Now, industrial robots application. As you can see in the diagram that how the robotic arm uses encoders with gray code. Each joint has an encoder that tells the system exactly how much the joint has moved. As you can see here, how the joint is moved here like this. So this is the industrial robot application. Now advantages. First, high accuracy. Gray code changes only one bit at a time, reducing the chance of misreads during transitions. Second, fewer errors minimizes glitches in digital systems, especially in mechanical encoders and position sensors. Third, high accuracy. Uh, Integration with logic gates, flip flop, and counters make implementation more straightforward and efficient. Okay, now quick recap. Let's quickly summarize what we have discussed in this session. First, what is Gray code? A binary sequence where only one bit changes at a time minimizes transition errors. Second, why it's important. Essential for accurate position sensing in robotics and automation systems. Third, how it works with digital logics. Uses logic gates, flip flops, and counters to decode and process signal efficiently. Fourth, where is it used? Found in encoders, robotic joints, and automated machines, reliable movement control. So, this is all we have discussed during this session. So, the conclusion of this session is gray code combined with digital logics forms the backbone of accurate and reliable motion control, making it an essential technology in the future of robotics and automation. Now, the reference. Here are some sources we used. Introduction to Robotics by John J. Kidd, IEEE papers on encoders, technical blogs, and websites. So, this is all from my side. Thank you so much for watching and learning with me today. I hope you found this session on Gray code and its application in robotics informative and easy to understand. If you enjoyed the content, don't forget to like the video, subscribe to the channel, and share it with your friends who are interested in robotics and automation. Also, feel free to drop your questions or thoughts in the comments. I would like to hear from you. Stay curious, keep learning, and I will see you in the next video. Thank you.